Hey, how's it going? Mr. Farrell here. And we're just going through another word problem. This one is focusing on the conservation of momentum equation in an inelastic collision. Okay. So we're going to go ahead and give this problem a read. And then we're going to go ahead and use the 4 steps of the ICE method: identify, categorize, equate, and evaluate, in order to solve this problem. All right. So the problem says, 2 football players collide in an inelastic collision. Player 1 has a mass of 120 kilograms and player 2 has a mass of 98 kilograms. Initially, player 1 is running 4 meters per second west and player 2 is running 7 meters per second east. After the collision, what is the velocity of the players? Okay. So we're going to go ahead and do the identify step, which is to write down all of the measurements in the problem and to write down the question. So let's go through this and see what our measurements are. Now, a measurement is any number and units. Okay, so when you see a number and units next to it, you want to write that down. So the first one we see is 120 kilograms. Okay, so we'll write that down. Next one, 98 kilograms. I'll write that down. Then we see 4 meters per second west. All right, we do want to keep the direction because this seems to be a vector, right? And vectors, with vectors, direction is important. Next, we see 7 meters per second east. All right. Cool. All right. So that seems to be all the measurements. Now, if anyone saw the 1 next to player 1 or the 2 next to player 2 and thought, well, why didn't we write those down? Well, again, these are not measurements, right? A measurement is a number with a unit next to it. So none of these other numbers have units next to them, so we leave those alone. And now we're going to write the question down. So what is the velocity of the players? All right. What is velocity of players? All right. And I know that this is after the collision, right? Because it says after the collision, what is the velocity of the players? So I'm just going to make a note of myself that this is after the collision. All right. Now, if you just watched the elastic collision video, you would notice that the velocity, there was one velocity for the first object and a different velocity for the second object. Now here it's saying what is the velocity of the players. So both players have the same velocity after the collision. Now that is because this is an inelastic collision. So the players stick together when they tackle each other and run into each other. So they're both going to be moving at the same velocity after the collision. And we'll see that more clearly with the equation we use. All right, so we just did the identify step, so we'll go ahead and cross that off. Now we need to do the categorize step. So this is where we go ahead and put all of our measurements as a variable. All right, we categorize them. So let me go ahead and write categorize over here. All right. Now, before we move on, there are 2 other things I want to do with this problem to, excuse me, to help me along with the identify step. So first of all, I know that this is an inelastic collision, okay? It's helpful to know that because that really tells us what equation we're going to be using, okay? Next is I want to square after the collision. So this is helpful because it just, when I go to categorize my variables, I'm going to need to know which variables are for before the collision, which ones are for after the collision, and being able to identify in the problem where after the collision is will help me make sure I put all of these measurements in the right category and these measurements in the right category. All right. So when we're dealing with an inelastic collision, right, this is really helpful to know because we already know what equation we're using. Now, normally in the identify step, when we begin to categorize things, we've got to look at every single measurement and figure out what category it falls into. However, here it's made easier for us because since we know this is an inelastic collision, we know all the variables that are involved in that type of equation. So let me go ahead and write down the inelastic collision equation as M1 times V1 plus M2 times V2. That's initial. And that is going to equal M1 plus M2 times V final. All right. So as you all can see in the equation, we are going to have two different masses initially moving at two different velocities. Then after the collision, we're going to add those masses together because both objects will stick together. In this case, both football players will stick together. And they're both going to be moving at the same velocity. Okay? So we're going to go ahead and write these down. All of these variables. Now I'm going to split them into categories. So this is going to be my initial. All right, so I have M1, V1 initial, and then M2 and V2 initial. All right, cool. And now for my final values, let's see, final. I have M1, M2 final. And then I have a final velocity, V final. All right, cool. Now, again, the reason, and I'm going to go ahead and erase this equation because I just used the equation to make sure I wrote all the variables that I'm going to need. Now, again, normally you won't be able to just write out all the variables you need because you don't know what equation you're using. However, this tells us it is an inelastic collision, so we already know what equation we're using, so we can just go ahead and write out all the variables we're looking for. All right, so now we're going to go to the identify step and put all of these measurements in our different categories. So we'll start with 120 kilograms. Now we know kilograms is a unit of mass, but we have to go back to the problem to figure out whose mass it is. Is it player 1 or player 2? So 120 kilograms. When I see it in the problem, it says player 1 has a mass of 120 kilograms. So we'll put this for mass 1. So 120 kilograms for mass 1. Now again, the mass doesn't ever change. So the mass initially of player 1 is going to be the mass after the collision, the final mass of player 1. So I'm going to go ahead and put 120 kilograms in both of those spots for mass 1. And I can cross it off this identify side. Next, 98 kilograms. Now, 98 kilograms in the problem, it says player 2 has a mass of 98 kilograms. So we'll go to player 2's mass and put 98 kilograms there. And also, player 2's mass after the collision is still going to be 98 kilograms because that mass doesn't change. So now we'll cross this off the list and we'll go to the next measurement. So the next measurement is 4 meters per second west. All right. Now 4 meters per second, we know that is velocity. All right. And we just need to figure out whose velocity it is. So we see 4 meters per second in the problem. It says player 1 is running 4 meters per second west. So I'm going to go to player 1's velocity. So V1. Initially, right? Because it would only be after the collision if it came after this statement, okay? But it doesn't, so it's still before the collision. Player 1 is moving 4 meters per second, okay? Now the direction is west. Now normally whenever we solve a problem, we can't actually put west in these variables because when we're evaluating an equation, we don't actually use the word west when evaluating the equation. So we need to figure out a way to represent that this is going west without actually writing west here. All right. And the way we do that is we use positives and negatives. So we are going to say that west is the positive direction. So any velocity that is heading west is going to be a positive velocity. All right. So this 4 meters per second is heading west. So I'm going to just put a plus sign next to it. So I know it is a positive 4 meters, which just means it is heading west at 4 meters per second. All right. So I'll go ahead and cross that off the list. Next, I see a velocity of 7 meters per second. Now, 7 meters per second is also a velocity, but this one is heading east, okay? It is player 2's velocity because it says player 2 is running 7 meters per second east. So I'm going to go ahead for velocity of player 2. I'm going to put 7 meters per second. Now, if west is positive, that means the opposite direction, east, has to be negative. So this is going to be a negative 7 meters per second. All right. Just meaning that it's going east. All right. Now, we did that one, so we can cross it off. In the final question, we actually only have one thing left to categorize. And that is indeed the final question. What is the velocity of the players after the collision? So we go to after the collision, which is everything that's in the final column. And we go ahead and write a question mark, right? Because if we don't know what we're looking for, then we're going to have a hard time solving an equation, right? Because we don't know what we're solving for. So we just categorized all of our measurements and the question. So we are actually good to move on from the categorize step. All right. Now, another thing to remember for the categorize step, make sure that you are labeling things properly. So velocity of object 1 was 4 meters per second west, which was the plus sign. Now that is before the collision. So you want to make sure that you label it with the initial side or before the collision starts. And then final side is everything after the collision. All right. So just be real careful on that because that can mess you up sometimes. All right. So we're going to go ahead and erase that. Now, another thing to note that I didn't bring up immediately. The cool thing about this problem is it gave us, it said player 1 and player 2. So we know that all of our 1s are player 1, all of our 2s go with player 2. But sometimes you won't have that in a problem. It might just say a ball and a car, right? And you're going to have to label which one is going to be object 1, which is object 2. So just to practice that, which I should have done this before, but I'm going to say object 1 is player 1. All right. And object 2 is player 2. And again, this is just so that we practice making sure we identify one of the objects as object 1, the other as object 2, so we categorize everything properly. Okay. So we just finished with the categorize step, so I'm going to cross that off. And I'm actually going to go ahead and erase this problem. All right. And we're going to go ahead and start on the evaluate step. Okay. Or sorry, not evaluate, the equate step. So the equate step is where we choose the equation for the problem. Okay. So we know that this is an inelastic collision. So we already know what equation we're using. So I'll just go ahead and write it up here. M1V1 plus M2 V2 equals, and now this is initial, so let me make sure to write that. Initial equals M1 plus M2 times V final. All right, awesome. So that's the equation for an inelastic collision. All right, now normally what we want to do is identify what variable we're looking for. Okay, so we do want to do that. We look through all the variables in our categorize step, and whichever one we put the question mark next to, That is what we're looking for. And the question is next to velocity final. So velocity final, I'm just going to mark it in a different color so it's easier to see. So velocity final is what we are looking for. All right. Now, normally I would say rearrange this equation using algebra, right? Don't plug in any numbers yet. Just use algebra to rearrange it in order to get V final by itself. Normally, that's what I would say. But because conservation of momentum problems have so many different variables in them, it's actually a little easier if you're not that great at algebra. It's a little easier to just go ahead and plug everything in immediately, okay? And that's what we're going to do. So we wrote a equate here. We did choose our equation, and now we're done with that. So we're going to move on to the evaluate step. Now, again, normally in the equate step, I would say rearrange this equation first. But because it is a conservation of momentum problem with so many different variables, we're just going to jump straight to the evaluate step after we choose our equation. All right. So evaluate. Great. Okay. So now with the evaluate step, we're going to go ahead and plug in our different variables. All right. So mass 1 is 120 kilograms. Velocity 1 is, again, plus 4 meters per second. So it's moving in the positive direction, which is west. Okay, mass 2 initially is 98 kilograms. And the initial velocity of player 2 is negative 7 meters per second. Again, negative just meaning it's going east, going in the opposite direction. All right. Now we come over here. Mass 1 is 120 kilograms. Mass 2 is 98 kilograms. And then we are still solving for the final velocity, V final. All right. Cool. So now that we have that done, we can actually, I'm going to erase everything for the categorize. From the categorize step. And we are just going to go ahead and solve this just like we would any problem. So we have 120 times 4, which equals 480. All right. Now my units, I have kilograms times meters per second. So I'm just going to keep that, kilograms times meters per second. Now again, this is a unit of momentum, which is good, right? Because this is the conservation of momentum equation. So I want to make sure that I'm getting the correct units for momentum here. All right, so I'm going to add 98 times negative 7. All right, so 98 times negative 7 equals negative 686. And again, the units are kilograms times meters per second. All right. Great. So now we're going to go ahead and add these two masses together. So that is 120 plus 98 equals 218. And again, the units are just kilograms, so we keep that. All right. And we are still looking for velocity final. So I'm just going to keep writing that in a different color so we are clear on what we're looking for. All right. So now I have to combine like terms. Okay. So currently my like terms here are everything ending in kilograms times meters per second. So we're just going to combine these on this side. So we have 480 kilograms times meters per second plus a negative 686 kilograms times meters per second. So let's go ahead and do that. That's negative 686. All right, cool. So this gives us a negative 206 kilograms times meters per second. Awesome. And then that's going to equal 218 kilograms. All right. And again, my velocity final is what we are looking for. All right, so what is the final velocity of both players as they stick together and fly through the air in a tackle? All right, so here we're almost done. Okay, we need to isolate the final, right? We have to get it by itself. Now, when I think about isolating a variable, I think about using PEMDAS. Please excuse my dear Aunt Sally, right? Parentheses, exponents, multiplication, division, addition, subtraction. I use it in reverse, okay? Now here it's easier. It's easy to see what we need to do without using PEMDAS, but I'm going to use it anyway. So again, if I'm isolating a variable, trying to get it by itself, I want to use PEMDAS in reverse. So we're going to look for any subtraction or addition first on this side of the equation. There is no addition or subtraction. So we're going to do the next step, which is to look for multiplication or division. Indeed, we do have multiplication because when these two things are written next to each other with no operation between them, we assume the operation is multiplication. All right, so if multiplication is happening, we need to do the opposite of multiplication to separate those variables. All right, so multiplication is happening here. So I need to do the opposite, which is division. All right, and remember, what I do to one side, I do to the other side. So I'm dividing here, and I am gonna, again, I'm trying to isolate V final. So I don't want to move V final. I want to move everything else away from V final. So I'm going to divide by 218 kilograms on both sides. All right. Now that helps us because when you have the same thing in the numerator and the denominator, they cancel out and equal 1. Okay. So 218 cancels with 218. Kilograms cancels with kilograms. All right. So I'm actually left on this side of the equation with V final by itself. All right. Awesome. Now I have to finish this here. So let's do negative 206 divided by 218. All right. Negative 206 divided by 218 equals negative 0.94. So negative 0.94. And now we need our units. We have kilograms up top and kilograms on the bottom, so they cancel each other out. And we have meters per second, but nothing cancels it out, so we keep the meters per second. All right. So it turns out that after these players run into each other, they're going to end up moving again in the negative direction. And we say it, the negative direction was east, right? So west was, we say it was positive, east was negative. So after these players tackle each other, they will end up moving about nearly 1 meter per second east, okay? That'll be the final velocity of both players. All right, cool. And that is the end of the evaluate step. So make sure that when you finish the evaluate step, you look at the sign and just make sure it makes sense, right? So both players were running into each other, and the person who was heading east actually had a higher velocity, right? So it kind of makes sense, right? If someone's running faster and they run into you and tackle you, they're probably going to carry you their way a little bit, all right? And that's exactly what happened. The person who is running east ends up tackling the person running west, and because they're moving a bit faster and they have a bit more momentum, they actually carry, they and the person they tackle end up moving they end up moving east still, right? Because east was the negative direction, so they end up continuing to move east a little bit. All right, so great. Continue to practice this stuff. Again, it takes a long time to walk through every step very slowly and explain it out. But as you better understand it, you'll be able to knock these steps out a lot faster. Again, remember to read the problem clearly. And if you know what type of collision it is, that helps you a lot because you know what variables you need to use, you know what equation you're using, and you know what variables you're going to have to categorize in the categorize step. So you can go ahead and write those all out. All right, thanks so much, and I hope you have a great day.